everyone. So today we are going to solve Codeforces 1103 Div 3 question number E. So friendly gifts. I hope you must have given a good read. So I'll directly jump to the understanding of the question. Then we'll come to the constraints. So here are the test cases that they gave. We'll take the last test case. I feel it represents it very best. So first of all, basically what they're saying is you have given an array, some elements, n elements. In that you have to take two subarrays of equal length. Let's call them as A and B. They have equal length, and when you sort these two arrays, the resulting arrays, whatever you will get, the adjacent elements should have difference is equal to 1, not greater than, not less than, equal to 1. So it can be, for example, 1 2 3 4, like this is after sorting, or some like 5 6 7 8. It can be anything from whichever number you want, but it should have a difference of 1 or between adjacent elements. Now this was the first part. The second thing is the array, but what we want to find is these two arrays when combined should also form a good array. This is basically a good array. This is a good array. So basically when you join these two good arrays, and these two should be non-overlapping, they should form another good array as well. So 1 2 3 4 5 6 till 8. Okay, this is a basic question. So in this case, like the test case I took over here, it is going to be 1 2 3 4 over here, and 6 7 8 9. About the length, we need to return the length as our answer, and we need to maximize this length. So this is our question. I hope you have understood the question. Now let's come to the constraints. The constraints are pretty interesting over here. That is 6,000, and we should also notice this part. Whenever you find something like this in the question, it's something related to frequency, or you need to store the elements, or some way or the other. You can think around in that range. So let's go to our solution part. So it's just a second. So basically there are two things to this. Okay, so you must have noticed that since our limits are 6,000, we can easily do an n-square solution, right? It's gonna be 12 into 10 to the power 6. You can easily do this, right? So this gives you a very big hint that, let's iterate all the arrays. If you just see quite well, like let's take this one array again. 1 1 2 3 4 1 6 5 3 1 6 5 7 8. You stand over here, you check, let's say for length 4 we are doing, you check this 4. Is this thing a valid segment? No, right? Because why would I say that this is not? We will sort this. It's already sorted actually. So when you sort this, you will see the adjacent elements, some difference is not equal to 0. So one thing we get from this is that we cannot have duplicates. We cannot have duplicates in the subarray. This is point 1 to be mentioning. Okay, let's go to next point. Next one, 1 2 3 4. You can see it. You just sort it, and 1 2 3 4. It's a good array. You can go to 3 4. This is 1 1 2 3 4. This is also a good array. You sort it, it will become 1 2 3 4, and it is a good array. You go to 3 4 1 6. Now this is not a good array. You do it, sort it. Now I want you to notice one thing. When you took 1 2 3 4, this element and this element, isn't the starting element is equal to, I'll just take it like this, the ending element is equal to starting element plus the length of it? because the difference is always going to be 1. This is 1, 1, 1. So what do we got? By the way, it should be length minus 1. My bad. What are you getting? This was x element, let's say. This is y. X plus 3 is equal to y, right? What is 3? Your length. So this is one another equation. Okay, that your start, that your end minus start should be equal to length minus 1. This is our second thing to be noticed. Now let's come back to our equation, earlier one. Just erase these few things. Third thing, where were we? On this array, right? Now you can obviously see 1, 4, 6, 1, 4, 5, 6. You can calculate this parts only, and you can just see that it's not forming. The difference is 5. You need a difference to be 3, right? So this is not a valid segment. So did you got the point that using this second point which we just proved, we can find if one particular subarray is valid or invalid. This particular statement gives you the validation of a subarray. And this can be checked pretty easily. Now let's move to 6, 7, 8, and okay, we don't have to iterate more on this. So you can think of that. You can take in. So one thing that can come to your mind is, let's take length for like 1 till n, and let's check all the segments in it, whichever segments are getting valid or invalid, right? So for segment checking, you take I and you take length, right? And you go on iterating. But it would be a little, I mean, it's not a bad idea, but it would be a little confusing, I would say. You can do it this way as well. I guess the first way which I solved it would be more efficient to understand. Uh, Basically, since we got a point on how to validate an as subarray, let's find all the subarrays which are valid. All valid subarrays. To check all subarrays, we do an ij loop, our basic n square loop, which is allowed. Our constraints are allowing it. So we run it from 0 till n. We run it from j0 till n. While going, we'll calculate on the go max and the min of that array. Okay, max is going to be your ending element after sorting, min is going to be a start element, and we'll apply the formula 1. You got some valid segment. Let's say you got some valid segment which has a starting point of I, ending point of j, and a length of l. This is your particular valid segment. Now what are you supposed to do with it? Because you need of same length, right? You don't need any subarray, you need of same length. Right now we just found out how to get a valid subarray. We haven't found out if it is valid, if it is what you can say, of same length, because we need two arrays. And obviously another one is that you need to concatenate them to, like, the concatenated array should be again a good one as well. So valid array, good array, whatever. So what you do is you take a vector, okay, something like a vector v of length. Let's take this as n for better understand length. What you're going to store in this is a pair. You can take, or better way I'll explain it like this, much better. See, since we needed to have same number of same length, we need same length, right? Same length. So we need to store some length for it to be distinguished. Like you need all the subarrays of equal length. So take a vector of length, and store all the indexes at which the array starts. And obviously, uh, index index plus length will give you the end one, like the j. So you don't need to really store the j part as well. You can calculate it on the way. So you'll store this, and then in each of this, you need to check now that now you found two a and b arrays in this particular vector of length, right? You found your two arrays a and b which have same length and which are valid as well. Now the third part comes. You need to concatenate them, right? That is our main part. How are you supposed to be doing it? Now let's take two arrays. 2, 3, 4, 5, 7, 8, 9, 10. If you see, this 5 can be calculated, right? And from this also can be calculated by just adding n minus 1. So you don't need to stir the last element as I said previously. So if you observe one thing, this particular thing, and this particular thing, they need to be consecutive. Basically, your 5 and this should have a distance of 1 only after sorting as well. How are you supposed to ensure that? Basically, what I mean is start s1 plus length minus 1 plus 1 should be equal to s2. This is s2, this is s1. What we did is added length, which is basically this is the end element, the whole thing. We added plus 1 for the d and we got an s2, right? If you see it very closely, let's cut this out. S1 minus S2, or let's do it like S2 minus S1 should be equal to length. That's our condition. 2, can you see it? S2 minus this should be equal to length. So that's our condition. But how are you going to find the min of both? So that's why over here, when we stored our length in ith vector, we are also going to store a min, which is basically our first element. The first element will give you s1 and s2, and length we are already having, and we can calculate this. This is our third part of the question. So what are we finally doing? Our first part was to validate it. In validate, you're gonna check the frequency should be equal to only 1, like cannot have duplicates. Another thing that was max minus min should be equal to length minus 1. Second part was we store the vector into, like we store all these segments in a vector length, like store it according to their lengths. And the third part was, and after the third part is to check our if, like, oh, I forgot to mention one thing, like just a second. Yeah, I just forgot to mention one thing, that you are storing indexes because you need to check if those particular indexes are overlapping or not. So if you store the index as I1 and I2, basically both of them should have at least length of gap, right? Or they would be overlapping. If this is like I1 and this is I2, obviously I1 plus L2, sorry, I2 minus I1 will be always greater than equal to length. But instead, if it was something like this, it would obviously not make sense. It should be at least n, right? So this was point I forgot to add, but it's understandable, right? And the next part was to check, that is s2 minus s1 is equal to length or not. And here we go. That's our solution to the problem. I'll walk you through the code once. So I took a vector pair. while calculating, I am taking the max, the min. Yeah, here's one thing as well I'd like to mark, that this particular thing, basically I was first using a map which I didn't realize much, but this would give you a TLE. I have a TLE on test case 11 because of this. So use a frequency map, because you were given it as 6,000. You can use it. You don't need to, you know, that was the hint for map. Later on, after that, I was checking if the frequency was unique or not. We calculated min max. We checked our thing and we added into our vector. Later on, I was iterating from the largest to greatest, so you can directly return off whenever you got the first right. You sorted them all according to the length, so you can just check the adjacent ones, right? Like, it's not necessary, sorry, my bad. Not adjacent ones, but uh, it will cost, like, reduce the cost. You just have to iterate from I till n, sorry, j till n instead of I till n. So just some cost savings. Sort it all. So this is our first index, like the first segment. This is a second segment, and we are just checking this. The index is greater than length or not, and the min minus, like the S2 minus S1 is basically L or not. And if you found it, just return the second.